Hey, what's up, dudes? New day. Here we go. Oh, we need to push to GitHub. Internet was down. So let's go ahead and do git push. Right off the bat. There it goes. Alright, let me start this timer. Timer is started. 68 minutes, had court this morning. Got back from court, took forever, of course. Court always takes forever. I'm not in jail, so that's good, right? Alright. So what did we do last time? Alright, so last session we did the same old. We finished save state. We started on the load state function. Stopped at line 343 in save logic. Extensions are good to go, so that's cool. This is now going to be changed to load state part 2. We're starting at 12:58 today. And we're going to go for at least an hour, obviously, but we're going to try to do a little bit more than that. Why does this say 6:05? That should be 6:10. Continued going through second final pass of save logic load state function to implement load logic associated with the master save object list. Alright. Alright, so we're good to go. Let's jump over here. And let's see what we need to do here. Alright, so we have the below function, supposed to be improved version of above function, review to ensure less lines and more functionally intelligent. This version is 5 lines less, and that's where we stopped. So next is to check against the first version to ensure this is logically proper in context of required usage. Alright. Okay, so we're going to look at load state, and we're going to see what should we do. Should we use this new one or should we use the old one? Alright, so in this one, what do we need it to do? Okay, so let's just think about this for a second. What we need it to do is to grab all the data from the database, because this is the load function. This is loading after reconnect, and it's going to load the data in, and then we're going to grab all the data. Well, and then what? Well, then we have to handle each one. Yeah, because some of them are in skeleton format and stuff, so they have to be handled properly. They are placed in the database in a particular order. They're placed in the database in the order of the master save object dictionary. Okay, so we have all the keys, which are the object names as strings. They are saved in a particular order using the ID column, and whenever we select them upon load, we order them by the ID. So this ensures that it returns from the database in the same order that it was saved to ensure proper order of operations for certain data that needs to be applied prior to others. Yeah, so that makes sense. Particularly connect path as con. So let's start at the top here. Yeah, and then it just needs to handle each one in the specific way that it should handle it, which we haven't actually added that code yet. We just like changed the preliminary section before that part yesterday. So let's go ahead and just go line by line through this. So we have grabs the timestamp last save from each backup database to see which one is most recent. Okay. So you get index equals 0, and then we iterate through the path in save data stable path and save data stable backup path. So these two paths are for the like final save states that we use with our database. So we have two of them, two different database files, and it's just basically a security measure to make sure if one of them gets corrupted, we have one to fall back on. So as we're iterating through each path, we're using the with context manager to connect the SQLite 3 to the path as con, so we have that database connection. We then get the cursor by cursor equals con cursor. Then we do cursor execute select value from save data, where object name is equal to placeholder, and that placeholder is going to be filled with the value timestamp last saved. So we're retrieving the timestamp last save from the database to see which one is first. But do we actually save this? Okay, so at the time we run the stable save state function, we do indeed use the timestamp last saved. So, or insert it into the database rather. So that is updated every time that we run the stable save state function. Yeah, and then it will save all the data in. Oh, so it doesn't add the ID. Does it add the ID though for the serialize and insert function? Let's see. So we have self object name data. Serialized data equals pickle dumps data. So it serializes that. Serialized data since value column in DB is blob type. Pickle dumps data. Must serialization. Okay, so it serializes it and then it inserts into the save data the object name, the serialized data, serialized data. So this auto increments, we don't actually have to explicitly handle the ID. It's already like it's automatically added. So I think it would take care of it in that scenario whenever we're working with the timestamp last saved. So yeah, timestamp last saved is properly added every time we run the stable save state function. This function, which creates a new stable save state in the database, transfers data from save data to save data stable. So wait, we don't get the timestamp last saved again? I think that we're missing something here. Because we get the timestamp, we create a timestamp last saved for whenever this function gets called, the stable save state function. But let's see. Stable save state function takes checkpoint ID, sets to none, current time, and then it serializes and inserts the timestamp last saved. And then it uses both. It uses the same timestamp for both of these. So like, the only way that we would have a different timestamp in this scenario would be if like this one ran but then it crashed before this one ran, because if both of them get run, stable and then stable backup, and stable backup, whatever order it's run in, they're both going to be using this same timestamp, which is fine because they're both like, it's the same data set. It's not like one of them is more current than the other. They're both equal to each other, so it's fine for them to have an equal timestamp. But that means we probably need to have code that accounts for that, so that we have a condition that handles for whenever the timestamps are exactly the same. Because if there isn't a max, you might get an error associated with that max function or whatever. That max method, I'm not really sure. I need to figure that out. So let's go ahead and add that to current issues. And we're going to call it timestamp last saved. And we'll just call this logic 6/11/25, and we need to ensure that we have a condition which accounts for fact that timestamp last saved may be equal to each other for both stable and backup DBs when running load state. Also need to determine if max function throws error if if the two values are equal to each other. So let's see real quick. So we use max. Let's ask ChatGPT about this. So let's say Python max. Does it throw error if two values are equal to each other? No, Python's max function does not throw an error if two more values are equal. Okay, so even multiple values are equal and the max and other maximum simply returns one of them, the first occurrence. It doesn't matter how many values tie for the maximum. Max always returns a single value. You need to find all the values that are equal to the max. You do something like, okay, does not throw an error if two or more values are equal. So it will just grab the first one. It simply returns one of them, which is the first occurrence. So yeah, basically it doesn't really matter. Because if they are equal to each other, it doesn't matter. So we're safe in that regard. So that's taken care of. So actually, we don't need to ensure that we have a condition which accounts. So whenever they're equal to each other, it will already be handled. So I will add a little note here above max, which states that. Well, I'll just add it inline. It'll be an inline comment. Max doesn't throw error if two values are equal each other. It doesn't matter. 100% safe. Okay. And we'll just put that right here in the... Why did it double that? I don't know. Alright, so that's taken care of. So yeah, timestamp last save. Actually, hold up. Let me look that up a little bit more. It's timestamp last save. That is run every time we do stable save state function. And stable save state function gets called... update database stable save state function. So this one does, it handles all logic associated with the vacuum into operation. So this one does, checks to see if the target path exists, removes it if it does, vacuum into while true with SQL is DB target cursor equals DB cursor DB OK. DB is not target cursor is none. And then we say if DB OK is not equal to OK, then we do OS remove, and then we do vacuum into again, and then we say else break. Okay. So all this really does is vacuum into. I want to change the name of this because I don't like them having... I know I changed this from vacuum into, but I'm changing it back, whatever. It doesn't matter. Stable save state function. So this is the one that sets the timestamp last save. Where does it actually get called, though? Do we not... Since we're using we aren't going to be using checkpoint ID because there's only 1x checkpoint with that system. Keeping it around just in case we end up using more robust system. This is a function that will get called at the beginning of the main while loop, which will inherently call save state and will also create the backups. That function call in client pi needs to be added. Okay. So that's only going to be called one time. This is the function that gets called one time per main while loop. And then we will end up calling save state. Which technically this is like, well, stable save state is fine. I don't like the naming. The naming is just very ambiguous here. So first of all, let's go ahead and change the update db stable save state function. I feel like that should just be called the vacuum into, because that's basically what it does. Or we could call it copy db function. We could even call it copy db vacuum function. Because what it does is it copies the database using vacuum into. And we specifically use vacuum to do the copy. And that's literally all it does. It copies it and then just makes sure it's a valid copy. And it copies it using vacuum into. So we say self cursor execute vacuum into the target path. And we're self cursor though. Okay, so because self cursor is associated with self.db and self.db is associated with the save data path, then that means it will copy the save data into either the stable or the stable backup. I believe that's how that works. So I'm pretty certain that is indeed how it works. So that's what we're going to do here. We're going to go... let's see. What do we do here? So yeah, we can just change the name. I just wanted to like refresh on that. So we'll highlight this real quick. And we're going to find all of them. And what we're going to do is we're going to change the name from update stable save state to, we're going to say copy db vacuum into function. Or we could just say copy db vacuum function. I just like that better. I just do. So we'll change it in this test file as well. All right. Now this one is called the stable save state function. And I don't know about the name of this. This one, well, one of them needs to be changed. Either stable save state function or save state needs to be changed. So what it really does, it creates a new stable save state. Or we could just say create stable save state function. But then we have the separate save state function. And what does save state actually do compared to the stable save state function? The stable save state function gets timestamp last save, then it let's see. Then it checks the path to see if we have the backup, to make sure that we have security here. And if we don't have like the second backup or the backups in case this fails, we create those backups. So what this actually does is it determines which database I feel like this should be different. I think that the way that we currently have it, where we do the current time, then we insert the timestamp last saved, and then we run save state, should be altered. I think what actually should happen is that we should probably call this function from inside of save state. So in the client file, we're actually going to call save state function. And then that will call this function. Because save state, this is really like not the main function. The main function is actually save state. Save state is really where all the magic happens. It uses the database to actually save all of the data. By iterating through the master save object dictionary. And then it ultimately ends up serializing and inserting the data into the database. So what we would do upon modification, or what I was just talking about, is we would add this code right here at the beginning of save state. And then we wouldn't call save state here, obviously. So let's get rid of that. We'll copy this. Checkpoint ID. Well, so we would move checkpoint ID to save state, actually. Yeah, we would change it. We would have it to where checkpoint ID was passed to save state, and this one is just going to be completely changed. So what did we... Okay, we removed that function call, which is correct. So let's see, remove that function call. Now we're going to copy this, the time. We're going to get rid of that. We're going to move this now into the save state. And so we have this at the very top. Current time equals time ns. Serialize and insert function timestamp last saved. And that's going to... Well, we can do that here. At the very beginning, we'll say with SQLite connection DB path is con, current time equals time ns. And then we do self-serialize and insert function, passing in timestamp last saved, and then current time. And this one we should probably modify to use the should this function be modified to use the DB connection from this context management? Because currently it uses the self.db, which is fine. So serialize and insert function, let's go over there and see what that would do exactly. So it takes object name data, it serializes the data, and it uses self.cursor, which is associated with self.db, yeah. Which is fine. We can always modify that in the future. So we'll add that to things to do, and that would be review logic associated with, what do we call it? Review the logic associated with serialize and insert function regarding whether to use self.cursor or the context managed dbcon from the context in which the function is called. And that should just say determine whether to use self-cursor or the context managed DB connection. I'm going to express the function is called. Be careful. Ensure done properly. Review all associated code. True. Last current time, should this function be modified to use the dbcon from this context management? Okay, so now we have save state, which uses the context manager. It does the current time. It is the one that calls, that sets the timestamp last saved into the database. So in case that the table hasn't been created, which I don't really know, like, do we actually need this line? I don't know. We're gonna have to review that. So there's still some like questions about how this is gonna be in the final state. whether we're going to use self.db at all or if we're just going to switch over to always using a context managed database connection. I don't know, we'll figure that out. Do we actually need this line, or do we need the other location wherein this same code is called, aka which line should be kept? Should they both be kept? I don't know. We'll have to figure that out. But just in case, it seems like we would want the table to be created first, and then we would do the current time and then the serialization of that and insertion of that into the database. And you know what I'm just realizing? Well, I was thinking about the fact that this would be the first thing added to the database. And then it's going to order it by the ID upon load. So let's go over here. We have load state, and what it does is we get for object name blob in cursor, select object name value. So it iterates through the database, which would have the timestamp last saved, and then it would have the it would also have, I thought we added like some other thing like the game ID and the client ID or whatever. Doesn't that get saved to the database as well? So order by IDs. For object name blob in cursor execute, select order by ID. Object value explicit blob. So we're getting the classification ID. Self master save object dict add object name. Gives us classification ID value. So this would include timestamp last saved, but we don't actually need that at this point. That is already handled. You see, that is already done. But it would be resummoned whenever we ran this code here. Whenever we ran for object name blob and cursor execute, select object name value, that would indeed summon it. So an easy way around this would be to add the timestamp last saved to the master save object dictionary. Otherwise, this would return a key error, right? So what we need to do is we need to find this dictionary up here. And we don't have timestamp last saved. I don't want to... Because there isn't... Where do we do split? Scrambled like an egg, baby. I'm scrambled like an egg right now. So, where is the split at? The split is associated with loading or saving. I can't really remember. That's for save, whenever we do object access from string function, passing in the object name key. Okay. So, what we'll have to do for now, I think, is... I mean, we could have another table that had the timestamp last saved in it. And that would solve our problem, because we would be just selecting from a different table. It really, like, is it that important though? Couldn't we just say for object name blob in cursor execute object value equals pickle loads blob? But then we would have to check every single time to see if then the ID was 1. But then I'm not sure if the ID is equal to 1. Does that make sense? So what we can do is, how about this? We'll just do a try, classification ID, and then accept, and this will be for the case in which we are loading in timestamp last saved. Which isn't associated with the master save object dictionary. So in the case that we hit an exception, so we'll say accept key error, because we wouldn't have that key, then we would just pass. Since we already handled the timestamp last saved immediately above, there's no reason to handle it again. So that avoids that issue. I mean, it is like, could we have just created a new table? Yeah, we could have created a new table. It kind of seems silly to have a new table, though, just for... It seems silly to have another table just for timestamp last saved. I don't know. I think I would rather create just a table for it, honestly. It'd have its own table. Because I don't want to have to do the try except, just because, like... I don't like doing that. I don't like having a set of code that applies to literally one instance. You know what I mean? It's just one thing. If it's just one thing, I don't want to create an entire code. Like, I don't want to have an entire try except for just one entry. You know? It's just not the ideal way. I think what would be better would be if all we would do is we say select value from, we'll call this timestamp. We'll just call it timestamp last saved. So from timestamp last saved, and then we will go down here to save state. Let's see, hold on. Here we go. So whenever we run the right here, timestamp last saved, but we would need to use a different table. So how would we know to do that? So we would just do like table equals timestamp last saved. Or this one could just be, instead of doing, we wouldn't want to check if every single time. If it's at, I don't know though, because we are going to be saving it every single time. But that's only like 1 out of 20 objects that are saved. We wouldn't want to check every single time if it's 1 out of 20. So, like, I would prefer to just explicitly run this one. Like, so let's undo this. Let's see here. Okay, so I'll see what we're gonna do. We're gonna instead, we're gonna go up here to serialize and insert function. And instead, we're gonna do like this. We're gonna copy it. Line 230. I mean, is this the perfect solution? No, I mean, it's a solution that avoids redundancy and multiple code execution for something like that. You know, like it's just more like I don't know, less wasteful. So now in this, we're gonna create the table if not exists, timestamp last saved, and we're gonna insert into timestamp last saved the object name values, and then the values placeholders on conflict object name do update set value equal to. In this case, we don't have object name, we just have. So this is just gonna be timestamp last saved. And then we have the serialized data and then the serialized data. So this is now, when we run save state, it's going to use the current time, get the current time doing time and s. It's going to serialize the data via pickle dumps current time, and then it's going to manually upsert. Well, then it's going to manually create using the context manage cursor database connection to create the table if it doesn't exist, and that is the timestamp last save table. It's going to have the two columns, the object name which is going to be text, and then value, which is blob. Honestly, we don't even need both. We don't even need both. We could literally just have the value. Yeah, we could literally just have the value. So we have create table not exist timestamp last save, and then it's gonna have just one column, and it's gonna be value, the value column, and it's a blob type. Times is used times since it's not associated with the massive object, and we don't want to have to check for this rare instance every single time the DB is updated. So we instead create its own individual table. But you could say, couldn't, like, since the timestamp is the first thing that gets saved every time we run the save function, wouldn't that mean we could just check to see if the ID is equal to 1? But again, that's still checking for a 1 out of 20 thing. Like, why would you do that? You don't want to check for something if it's only a 5% chance of happening, as to where you could just have, you know, a separate table. Like, what's the big deal? There's not a big deal. It's a different table. Like, who cares? Does anyone care that you have another table for timestamp last save? No. It's just, it's fine. So we're just going to leave it like this. So we current time, serialized data, cursor execute, create table. So there's creating a table in the same database, but it's just a new table. It's timestamp last save. It's going to have one column called the value. It's going to be blob type. Then we verify that DB is updated, so instead created its own individual table. Verify this upsert method is fast to be tested. Now change to insert or replace because that is slower. Insert in timestamp last save, and then here we're just gonna have value. Values on conflict. Well, we're not gonna. So on conflict value, do update. So we're gonna check to see. We're inserting it into timestamp last saved. The value is going to be on conflict of the value, meaning if the value already exists, if it's the same. On conflict means if it's the same. No, that's not true. It should say on conflict should be triggered. Wouldn't on conflict be triggered in the case that the, like, we're trying to do an insert into the timestamp table, we're passing in a value, and then on conflict, I was understanding on conflict to refer to the fact that if the object name already existed in the database, then we would update it. Yeah, and that makes sense. But what about if we only had one column? How would on conflict work there? Because the value wouldn't be the same, therefore it wouldn't be a conflict. So what would it do actually? Let's see. So we have timestamp last saved. We're not gonna have this anymore because, yeah, we just do. This would just be serialized data. Serialized data. Okay. Let's see how this would work. If we are using only one column, a serialized float would on conflict trigger if the floats were different values? Something seems to have gone wrong. Okay, let's try that again. Okay, ChatGPT is having trouble for whatever reason. Don't know why. I mean, on conflict, I'm just not sure about this. This is using Python with SQLite 3. Alright, Gemini, you've hit on a common point of confusion on conflicts with single columns in SQLite. Does on-conflict trigger if the floats were different values? No, on-conflict will not trigger simply because the new serialized data float value is different from the existing one. Conflict target. The on-conflict calls SQLite, specifically the upsert syntax on-conflict column name do update set, requires a unique constraint or primary key on the value column to identify a conflict. Without a unique constraint or primary key, SQLite has no way of knowing that an existing row is related to the new row you're trying to insert. It would simply insert a new row every time, even if the value... Okay, I'm an idiot. Of course, I should have known the answer to that. If you have a unique constraint or primary key on the, and you try to insert a row where the value is a negative value already exists, enabling conflict. The do set value equal question mark part then specifies what action to take when that conflict occurs. In your case, it will update the value column of the existing row with the serialized data you're trying to insert. Assume your timestamp last save table has a unique constraint on the value column. SQL create table. This is... is real. Let's see. Proper type for float for time.time ns, not blob. It's not the most appropriate revision type for non-nanosecond timestamp. Time returns integer representing nanoseconds in the buckets number of very large. The best one is typically integer. Is it an integer though? Time and s? I thought time and s returned a float. Oh, it doesn't. It returns an integer. Oh, right, because it's time. I remember. We don't use time.time is float. Time and s is integer. Gotcha. So we say import time, time and s. Yes. Okay. So this is just a reminder. We'll call it time.time ns is equal to integer type. The date 6/11/25. Then we put reminder that time.time ns returns an integer including nanoseconds, not a float. So hopefully that will help me remember that. Okay, so in that case we would use time ns returns this number can be very low. It's typically integer. Here's why: SQLite 64. SQLite is it for SQLite 3? This is for SQLite 3. Let's see. Yes, absolutely. Advice regarding the integer type and if it's discount limit 1 per second resistance. Let's let's see. Proper returns an integer representing the system since the epoch. This number can be very large. Typically integer. Here's why. Integer in SQLite is 64-bit. SQLite's integer storage class is a signed integer that can store values up to a really huge number. This is ample space for a nanosecond since the Unix epoch for many, many years to come. Time NS will give you a large integer, but it will fit comfortably within a 64-bit assigned integer. Storing it as an integer maintains a nanosecond precision presided by time. Integers are highly efficient for comparisons, which is crucial for time-based data and the floating point issues. Using real floating point for timestamps can introduce precision issues, especially with very large numbers. Okay. And it's faster than blob. If you're storing time at large integers using integer sequence running faster, more efficient than blob. Integers are native numeric type in data type in SQLite. The database engine is highly optimized for storing, retrieving, comparing, and indexing integers and understands their numerical properties directly. Blob is a generic container for raw binary data. When you store an integer as a blob, SQLite treats it as an opaque sequence of bytes. It doesn't inherently know that it represents a number. SQLite's integer storage class is designed to be space efficient. It uses a variable length integer encoding. The values restart to the point is some ways to introduce certain integer bytes. Okay, gotcha. So it's just better, right? So we'll use integer. So this would be creative not exist time last save, and we're gonna have to have two types. So we're gonna have or two columns rather. So we're going to have the object name, which is text, and then we're going to have value, which is going to be integer. TB used explicitly for time to save, do not associate with verified that this absurd method is fastest via testing. Okay, insert into timestamp last save, object name, value, values on conflict, do update set, value equal to timestamp last save, serialized data. Okay, but we don't actually need to serialize the data. We could just pass in the current time straight up. So we would just say current time, and we're going to stop here. This is line 234 in save logic. Yeah, so we're going to review that when we come back. We also have to make it to where we're going to be adding the save state function call, not the stable save state function. Stable save state function is going to get called at the beginning. So this is, so checkpoint ID is going to get moved. We're going to say, let's do the 6:11:25 below function move checkpoint ID param from this function to save state function, because that is now going to be the one called from client.py, not this function. And then what we also need to do, call this save state to do. And then we'll have another one, and that's going to be so this is going to be called at the beginning of save state. Stable save state function is going to be called at the beginning. Or, well, no, actually it's going to be called at the end, right? Because save state was previously called, we save and then this does the backup. So this is really creating the backups. So we'll rename this, and the to do is going to be rename this to something like create backup DB's logic func, since that more accurately describes what it does. And then we also need to add in function call to this function. Add in function call to this function at the end of save state. Yeah, at the end of save state. And then what we need to do lastly is add in a function call to this function inside of client pi 1x per main while loop. And I think I got all that right. And I did change a lot of stuff around here, but overall I think I got it right. I think I'm not like 1000% sure, but I'm pretty sure that I got this right. So I didn't get to review it, but I'm gonna go to the gym, and I'm gonna go to the gym. I'm gonna take a shower, and then we're gonna come back and we're gonna do another session, because I'm gonna get back to those 2 a day for sure. Because this, I fell off big time with my time. And then we'll put after next. See above caution comments for this function and next function up. Next functions up for next tasks. Review all work. Be careful. Because I was kind of like rushing a little bit with that, but I'm very ready to be done with this, but I do need to be careful. You can't just throw shit up there and expect it to work. It doesn't really work like that. You have to be very careful. Okay, so we are at the root of the project directory, so we're going to do git branch to ensure we're on the right branch, which is new feature. That's right. Now we're going to do git add dot to stage everything. Now we're going to do git commit -m, paste in that devlog, and hit enter. Now we made our commit successfully. Now we're going to do git push. This is going to push up to the remote repository, the cloud, GitHub. There, it did that successfully. Now we can exit out of this MSI Afterburner. Ain't worry about that shit. So we go over here to programming projects Canasta, copy the current one. We go to backup, rename this to be 611, and then we're gonna delete the old one. We're gonna paste in the new one. Enter into it, go into text, devlog, go all the way to the end, and we have 215. Yep, so that is indeed up to date. Alright, so we're done for now. That was pretty good. It's a little hectic, you know. There's like, this is the final stage, and this is how it is. I feel like I'm gonna move this a little bit. I'm gonna change this name space. I'm gonna, you know, take care of these little details that need to be shifted around a little bit to just be nice and like tight and sensical. Things get a little scattered, and it's nice to just organize as you go instead of letting it get like out of hand per se. So did a little bit of housekeeping, I guess you could call it there. Did go a little fast, so I'll be needing to review all that to make sure everything is perfectly in order. I don't think I made any mistakes, but that's why I go back and do a review after each session. So we'll do that next time. Anyway, I'll see you guys in a little bit. Look like we only got, since we're going to do one more today, I would say we could probably finish the load state function today, this next session, if I don't fuck around and like just knock it out. And yeah, then we can just go ahead and like do the last final touch-ups on the entire system. Make sure we got all our function calls in the right spot. Make sure we're using the right namespace, etc. And then we can go ahead and start testing this shit, dude, and move on to something bigger and better, and you know, see the final working product. So we're gonna be doing some debugging soon. All right, dude.